Hi, Dahlia Remler again. So now in this last sampling video, we're going to talk about complex survey sampling. So these are all probability-based sampling methods. They all have some kind of random approach, but they're more involved than just getting a population and randomly selecting people from it. They're more involved than simple random sampling. And really, they're much more common, especially in like the big government and other well-established surveys. The first approach is the simplest and oldest of these. It's called systematic sampling. And it's used when you don't have a list to use as your sampling frame. It basically has, or rather, you can use it with a list, but it's often used today for things like exit polling. And the idea is you have a bunch of people coming through in some order, and you make a random start, and then you ask to speak to, say, every 20th person, every nth individual. So imagine people on election day walking out of a polling place. You arrive at some time, you just pick one to start, and then the exit pollers ask every 20th person walking out. And then every 20th person becomes their exit polling sample. It's also used in a lot of physical locations, at a mall. Remember when we went to malls, or a corner, or the student services. And in the old days, when we didn't have computers, they often literally took a physical list and went every 10th person on the list. The next one is widely used. It's called stratified sampling. You take your entire group, entire population, you divide it into groups, exhaustive and mutually exclusive group. Exhaustive means everyone belongs to one group, and mutually exclusive, they belong to only one group. Then what you do is you draw a sample, a simple random sample, separately from each group. Why do you do that? It's when things vary a lot between the groups and you don't want to, say, get too many. So here's an example of stratified sampling where we've divided the United States into the 4 census regions. And then you'll take a simple random sample of people from each region. For things, perhaps early on, say, experiences of COVID, where things vary a lot between the regions, this is important because you don't want your sample by chance to end up missing, having a bunch of extra people by chance from the Northeast than from the South with very different COVID experiences. A variation on stratified sampling is oversampling, also called disproportionate sampling. But it's also quite different. So again, you start by dividing your population into exhaustive and mutually exclusive groups. So think of the labor force of the United States, people who are working or trying to work, and they're either employed or they're unemployed. But the majority are employed, at least in most times, even today. And so if you were to just do simple random sample or even stratified sampling, your sample would not have nearly as many unemployed people. That's not good if we want to get really precise information about the smaller group, the unemployed group. but without making a much larger sample where we're kind of wasting sample on the unemployed because we already have plenty of precise statistics for them. So what is done in that case is, like stratified, you take a simple random sample of both, but for the employed group, the larger group, you sample at a lower rate, whereas for the unemployed group, you sample at a much higher rate. Then you might decide that so that half of your sample is employed and half of it is unemployed. And that's great because you can separately get precise statistics with small enough margins of error, narrow enough confidence intervals for your unemployed group as well as your employed group. Oversampling is often used if you want to find out about minority groups of any kind. You'll oversample. But if you do that kind of oversampling, and you also want to know about the population as a whole, you have to weight the sample. So to get statistics representing the whole population, you need to weight. And what that means is that the population average, like stuff about statistics for everyone in the labor force, will be equal to 0.94, 94% times whatever the average of that statistic was for the employment, and only 0.06 or 6% of whatever the average was for the unemployed. So for the population as a whole, the group that you sample disproportionately has to be weighted much lower to get averages for the whole population. This effectively lowers the sample size for the whole population because, like, hey, half the people in your sample, say you had a sample of 500 people in total, 250 of them were unemployed, but they're only counting 6% towards that statistic. So you don't have, it's not like you have 250 of them and 250 of the employed. The 250 unemployed don't count as much. There's a lot of software to figure out your standard errors. I'll talk more about that soon. This is not only true for oversampling, but it's also true for cluster sampling and other forms of complex survey sampling. Now, maybe you thought that stratified sampling sounded an awful lot like the quota sampling we talked about with non-probability sampling methods, because they do kind of seem at first. You take your population, you divide it into exhaustive and mutually exclusive group strata, so everyone is in one group, but only one group. And then you sample separately within each group. And in fact, stratified sampling and quota sampling are identical in those ways, but then they differ. Stratified sampling randomly samples within the group. Quota sampling doesn't. In some forms, it can even be a convenience sampling. Yeah, I'll take anyone in that group. Fine, you're all the same, effectively. So stratified sampling is representative within the group, and therefore, provided you really know the weights of how the share of each of your groups within the population, it's representative of the population. Quota sampling is potentially not representative within the groups and therefore not representative of the population. If quota sampling is going to be pretty good, then it has to be kind of the case that people within the groups and being within that group, it's kind of destiny. So if you divide everyone up into these small demographic groups, like I was saying, you know, men 24 to 29 years old who are white from the South, high school graduates, that once you know that, say, that's all you need to know who they're voting for, quota sampling will be okay, but it can be problematic. However, quota sampling has become more and more used in the internet era, particularly in what they do with those internet panel surveys, because they have a lot of information about people. They got demographics, but they know a lot about you and maybe can a lot about you that's relevant to your politics. So it's kind of made a comeback from being disreputable. The next form of complex survey sampling I want to talk about is cluster sampling. Often we don't sample the individuals directly, but we first sample them in clusters, aggregate, and then we get to the individuals within the cluster. So, for example, maybe you don't have a list of high school students in the country, and so first you sample high schools and then you sample students. So that can be because you didn't have a list. But a lot of cluster sampling is clustered geographically, particularly if you want to do things in person to avoid expensive travel. And it requires weighting and correcting your standard errors. So let's look a bit more about what a simple cluster sampling might look at. Supposing you want to survey bus passengers. Well, you don't have a list of bus passengers. And also, they may be spread out. So what do? You first get a bunch of lists. Maybe you had a depot, you get a list of buses that are going to depart there. You randomly sample the buses. Then you get all the passengers on the bus, and that creates your sample. So first you randomly sample the clusters, the buses. We're thinking of buses as just clusters of passengers. Then you survey the passengers within each of those sampled clusters. That example is a census of passengers, but you can also see cases where you would sample the passengers within the bus. The last thing I want to talk about is the fact that standard errors, confidence intervals, p-values, any of those inferential statistics are much more complicated when you use complex survey sampling, like when you use oversampling, cluster sampling, and so on. That basic standard error formula was based on simple random sampling. So the standard errors have to be corrected. It typically increases the standard errors, like that oversampling example when I said, hey, half your sample was the unemployed, but they're only contributing 6% to the population measures. A number of statistical software packages have commands to make these corrections. You have to give it the correct complex survey sampling information. Stata does, SAS does, SPSS does not. An alternative approach, if you don't have that, is something called design effects. And surveys using complex survey sampling will tell you their design effect, and that takes into account the loss or occasionally gain in precision. Design effect of greater than 1 means that what you're getting because of the complex survey sampling is less precise than a simple random sample. That's the usual case. You can see the opposite. Design effect less than 1 is more precise. Okay, so that's it for complex survey sampling, the more involved versions of probability sampling. And it's also it for the whole sampling chapter in general. We've most often talked about sampling when you want to sample people, occasionally when you want to sample organizations. But remember that sampling is much broader than that. We sample air quality, take samples of the air to look at air quality. You can take samples of data. If you have an administrative data set, you can try and sample stuff on the internet. So sampling, you can also talk about sampling really to get at anything, any kind of case or anything you want to analyze or study. Okay, so that's it. Feedback is really welcome. There were a number of diagrams that we're developing for the 3rd edition, so that aren't in the 2nd edition, so I particularly appreciate your feedback on that.